Let's look deeply into what's going on kind of behind the scenes in a lot of interesting math stuff. So we'll do some fun with power series and complex numbers. Let's remind ourselves that I is the square root, is what we call the square root of -1. Engineers call it j, but I'll keep using I. I squared would be the square root of -1, so that's -1. I cubed would be I times I squared, which would be I times -1, which would be -I. And you can do a bunch of math there, and you see this I, -1, -I, 1. And then I, and then we'll get a -1, because we'll get I to the 4th times I squared, which is -1 times 1. So this will end up being -1. So we seem to see kind of a repeating pattern here, right? It takes 4 iterations to get back to where we started. Kind of interesting. Let's combine that idea with our Maclaurin series for e to the x. And let's say, what's e to the ix? So there's no x in this term, so that's just a 1. Instead of x here, I'll just do ix. And then I'll do ix squared over 2 factorial, ix cubed over 3 factorial, ix to the 4th over 4 factorial, ix to the 5th over 5 factorial, etc. And now let's break out this squaring. That's squaring each component and multiplying them by each other. So we'd get 1 plus ix plus I squared x squared over 2 factorial plus I cubed x cubed over 3 factorial plus I to the 4th x to the 4th over 4 factorial plus I to the 5th x to the 5th over 5 factorial plus dot dot dot. And now let's use our table up here to simplify things like I squared and I cubed, etc. So this is still e to the ix. So we have 1 there, and as I simplify things, I'm going to write these on 2 different rows depending on whether they have an I in them or not. So 1 doesn't have an I in it, so I'll leave it on this row. The ix here I'm going to put down here. And then this, I squared is -1, so all the i's are gone, and I'll have a -1 times x squared over 2 factorial. And then I cubed, what is I cubed? Up here we said it's -I, so I have an I left there. So it's -I x cubed over 3 factorial. I to the 4th is 1, so I get a +1 x to the 4th over 4 factorial. And then I to the 5th was I, so again that goes in the row down here with i's in it. X to the 5th over 5 factorial plus dot dot dot. And now let's look at what we have. We have 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. That's basically cosine. So that's our Maclaurin series for cosine. That's the real part. And then here I have x, if I ignore the i's, I have x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. So that's sine, but each term is multiplied by an I, so I can kind of factor out an I and say plus I times sine of x, which is really interesting. It's saying e to a complex or imaginary power is basically a combination of sine and cosine with some imaginary stuff going on. So that says when we're adding up sines and cosines, we can rewrite it as complex powers of e. And we know that powers of e are easy to integrate and differentiate, even easier than sines and cosines, so that's kind of handy. So this basic idea gets used in Fourier analysis, which is used in many, many places. Right now, all of our cell phones are doing Fourier analysis on the radio signals they receive from the cell phone towers to take out the noise, and they're doing Fourier analysis before they transmit information back. So it's used in signal processing. It's used in electrical engineering. all kinds of other applications. We can take this idea and write it for a special case, and that is, what if I do e to the I pi? That would be cosine pi plus I times sine pi. So we're saying e to the I pi, cosine pi is -1, sine pi is 0, and so this is saying e to the I pi equals -1, or e to the I pi plus 1 equals 0. And people say that that's one of the most beautiful equations in math because it combines 5 fundamental constants of math, e, I, pi, 1, and 0. So that's true. I've known mathematicians who have tattoos of this. But I think it's not quite as interesting as this, because this is useful in a bunch of applications, and this is just kind of one single solitary fact. It doesn't have any x's in it that you can plug in. So I think this is more interesting.